Hello there, Wildcats. In this video, I'm going to discuss about proving quadrilaterals as a parallelogram. So, in the first theorem, we have theorem 6-11. This is the converse of theorem 6-7, which is about sides of a parallelogram. Now, if both pairs of opposite side of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So just like what we have here, as you can see. So if AB is congruent to this CD, and we have AD is congruent to BC, then this given quadrilateral ABCD is an example of a parallelogram. Now let's take a look at this example, or this example here.
Part A. Teo sketches a design of a parallelogram-shaped building. If angle 1 is supplementary to angle 2 and angle 4, is his design a parallelogram?
All right, to answer that question, one of the given, it says there that angle 1 is supplement to angle 2 and angle 4. So angle 1 is supplement to angle 2 and angle 1 is also supplement to angle 4. All right, so since angle 1 and angle 2 are same side interior angle and supplementary to supplementary, the top and the bottom sides are parallel. Okay, so the top here is also parallel, and angle 1 and angle 4 are also supplementary. It's the same. So this side here is also parallel to this side. Therefore, the quadrilateral has two pairs of parallel sides, so it's a parallelogram. So remember, by definition, opposite side of a parallelogram, okay, opposite side of a parallelogram are parallel. Use this theorem, okay, about the parallel lines to show that the quadrilateral is a parallelogram. So by definition of a parallelogram, we can consider if two both opposite sides of a quadrilateral are parallel, then that quadrilateral is considered to be a parallelogram. Now, to answer that question, is the design a parallelogram? Yes, the design is a parallelogram. Now, how about letter B?
Part B. Teo sketches a second design in which angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4. Is that design a parallelogram?
So we will answer that. So it says there that angle 1 is congruent to angle 3. So we are now looking at the opposite sides of our opposite angles of the quadrilateral, and angle 2 is congruent to angle 4. So they are opposite side. So the sum of the interior angle is 360. So let's take a look at that. So if I'm going to put there the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 plus the measurement of angle 4 is equal to 360. Now, because these are all congruent, okay, so you will see that angle 1 and angle 2 plus angle 1 and angle 2. Okay, so it's like there are two angle 1s, which is 1 and 3. So there are two angle 1s. So the measurement of angle 1 plus the measurement of angle 1, or I'll just the measurement of angle 2 plus, it says there that angle 1 is congruent to angle 3. Now, instead of putting angle 3, because angle 1 and angle 3 are congruent, then I'll put there angle 1. And then instead of putting angle 4, you said that angle 2 is congruent to angle 4. So instead of putting angle 4 there, that's the measurement of angle 2. That is 360. Now, there are two angle 1 and two angle 2. So I can put there the measurement of angle 1 plus the measurement of angle 2, which is equivalent to 360. Okay, therefore you can now divide this one, the entire equation, with 2, Therefore, we have angle, the measurement of angle 1 plus the measurement of angle 2 is equal to 180. So you can now say that when you substitute 4 for 2, then angle 1 plus angle 4 is equal to 180. Angle 1 plus angle 4 is 180. Angle 1 and angle 2 is equal to 180. All right. So we can now have, because the edges form a quadrilateral with one angle supplementary to both consecutive angles, and from the result in part A, the second design is also parallelogram. Right? So that's it. Right. All right, let's go with our next theorem. So in this theorem, we have two theorems here showing in your screen, which is theorem 6-12. It is the converse of theorem 6-8, and also theorem 6-13, the converse of theorem 6-9. Now let's focus on 6-12. If an angle of a quadrilateral is supplementary to both of its consecutive angle, then the quadrilateral is a parallelogram. Now, based on the illustration here, if quadrilateral A, B, C, and D, if you add the measurement of angle A plus the measurement of angle B, it's 180, and the measurement of A and angle D is also 180. Then ABCD, or quadrilateral ABCD, is considered to be parallelogram. Now let's apply that in this. So for what value of R? So we're just only looking for the value of R and S. Okay, what's the value of R and value of S? Sorry about that. It's the value of R and S in quadrilateral WXYZ, a parallelogram. Okay. So let's take a look at, let's start with WX and YZ. So we have 4R, so we can say 7R plus 1, this one. Okay, I'll just do it again. YZ, okay, segment YZ is equal to segment XW. So your YZ is 7R plus 1 is equal to 4R plus 7. Okay, so combine like terms. So 7 minus 4, that's 3, and then 7 minus 1 is so we have 3R is equal to 6. Then divide both sides by 3, so R is equal to 2. So the value of R is equal to 2. Okay, next is we also have we can say WZ is equal to XY. So the measurement of WZ is 2S minus 2. So 2S minus 2 is equal to XY is S plus 5. So combine like terms. So we have 2S minus S is just S. And then we have, so because this is negative, so you go there. So 5 plus 2 is 7. So the value of S here would be 7. So that is the application of theorem 6-12. So if the angles inside are supplementary, then the given image is a parallelogram. Now in 6-13, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is also parallelogram. So in this image, angle A is congruent to angle C, and angle B is congruent to angle D. Then this ABCD, quadrilateral ABCD, is a parallelogram. Now let's take a look at this one. So if this is a parallelogram, then what will be the value? What are the values of A and B in parallelogram RSTU? So maybe I can I can start with the first one will be angle S and angle U. So let's start with that. So the measurement, okay, the measurement of angle S is equal to the measurement of angle U. So I can say that angle S is 5A degrees is equal to 3A plus 14. So because this is positive, if you go there, it will become negative. So 5 minus 3, that will give you 2A is equal to 14. Divide both sides by 2. Okay, so A is equal to 7. So the value of A is 7. Now the same with R and your T. So R, the measurement of angle R, is equal to the measurement of angle T. Plug them in. So I have 4B plus 1. So 4B plus 1 is equal to 3B plus 37. So this is 4 minus 3 because if I'm going to transpose that, it will only be B. So 37 minus 1 would be 36. So the value of B would be 36. So that is the application of theorem 6-12, which is the converse of 6-8, and also theorem 6-13, the converse of theorem 6-9. Now we go to the next theorem, which is the converse of theorem 6-10. It's on the diagonals, and then also theorem 6-15. Okay, so let's focus on theorem 6-14, which is the converse of 6-10. If the diagonals of a quadrilateral bisect each other, meaning you divide the diagonals into two equal parts, then the quadrilateral is also a parallelogram. So in this example, we have, sorry about that again. So we have your diagonal AX is congruent to CX and the diagonal BX is congruent to DX. Then your ABCD is a parallelogram. So now let's apply that in this example. So if AE is x plus 2, so AE, this one, AE is x plus 2, and CE is 2x minus 2. And DE is x minus 2. DE is x minus 2. So what for what value of x is ABCD a parallelogram? So meaning what will be the value of x to make this quadrilateral to be parallelogram? We said that they bisect each other, so we'll be using this one, this complete given here. So segment AE is congruent to segment CE. So I think those are the information that we need. So AE is x plus 2, AE is x plus 2, is equal to CE is 2x minus 2, 2x minus 2. So we can, I can subtract 2x both sides, and then subtract 2 both sides. So of course this will be cancelled. This will be cancelled also. That is negative 3x is equal to negative 4. Oh, sorry about that. I committed a mistake here. This must be x minus 2. That is negative 1x. Sorry. So that's negative x. Therefore, I'm going to divide this one by negative 1, negative 1. So cancel that. So x is equal to positive 4. So the value of x is positive 4. So ABCD is a parallelogram if, okay, if the value of x is equal to 4. Now in this another example, so for what value of P and Q is ABCD a parallelogram? So what will be the value of P and Q so that this quadrilateral ABCD will be considered to be a parallelogram? So I'm going to get 7P is equal to 5P. So 7P plus 1 is equal to 5p plus 3. So I'm going to subtract, that is 7 minus 5. That would be 3p. 7 minus 5, it's 2p, sorry. I'm looking at the 3 there. So 3 minus 1 will be 2. So divide this 1 by 2. Therefore, p is equal to 1. Okay. Another one is I'm going to get a 3q. So that's 3q plus 1 is equal now to 2q plus 3. So we have 2q plus 3. So 3 minus 2, that's just q, is equal to 3 minus 1. It's 2. So q is 2. Therefore, quadrilateral ABCD is a parallelogram if P is equal to 1 and Q is equal to 2. Okay, so those are the important theorems about proving quadrilaterals. So you have to make sure that you have to remember those theorem that you can use to prove a quadrilateral is a parallelogram. So if you want to go over with this video, you can watch it again, and then we'll see you in the live Zoom for some questions about this one. Thank you guys, and we'll see you in the next video. Bye-bye.